Okay, so here in this problem, we're going to continue on with our exam review. As I said before in a prior video, this is not all the questions that will be limited to your final exam in college algebra. But however, this does give you a good basis of which you can choose to further review topics that you feel are not your strongest. So hopefully, this is giving you some ideas of past sections of questions and sections that maybe you were not as sure about, or maybe you haven't seen in a while. And this question specifically deals with transformation. So this question is a transformation question. So in this circumstance, we have our base function. Our base function is square root of x. So this is our base function, square root of x. And in part A, we have a vertical shift. When it's shifted down, we know there is a vertical shift down 5 units. So in order for us to annotate correctly a vertical shift, we are going to say this is going to be f of x equals to square root of x minus 5. The vertical shifts are going to be outside of that radical. They're not going to be part of that radical. They're going to be outside of that radical. So in part B, and that's all we have to write, is that we're going to identify the transformation by stating that we have the square root of x, which is our base function, shifted down 5 units. So in part B, if we rotate around the x-axis, so if we look at our two axes here, that we originally have this being square root of x, and now what we're going to do is that we're going to rotate around the x-axis, and we're going to have something that looks like that. So we're putting a little knob here at the end, and we're rotating around. So we know that we're going to rotate about the x-axis. So that means that we are going to have to negate y. So negating y is the same thing as saying negate f of x. So in this circumstance, we are going to have f of x. We have to negate our function. That will just equal to the negative square root of x. So, and again, if we want to check ourselves, we could always plug it into our calculator to make sure that we have the correct answer, or we could plug in points. We could plot points. We can use a t-chart of letting x be a value and then finding y or f of x. For example, when x is 0, y is still 0. When x is 1, y is negative 1. So we realize that we're going further and further negative, which means that we have to correct the correct augmentation. So at part C, now we're taking f of x and rotating around the y-axis. So now we are rotating around the y-axis. So in this circumstance, we have our base function square root of x, and now we're going to rotate, and we'll do this in green, we're going to rotate this like such. So in order to get this, we spun the top right here. So we put a little corkscrew at the top, and we're spinning the top y-axis, so we have this augmentation. In order for this to happen, we negate the opposite. So if we want to rotate around the y-axis, we're going to have to negate x. So we're going to have to negate x. So notice in this circumstance, we negated the entire function, but in this circumstance, we are just going to have to negate our value of x. So we're going to put the negative with the x. By doing so, we have now rotated around the y-axis. And now we are going to have a shift. We're going to shift 2 units to the right. So if we shift to the right, we're going to have a horizontal transformation. 2 units to the right. So in order for us to note this, we know that if it's a horizontal transformation, we're going to have to attach this value of 2 to the x. So we recognize horizontal transformations will occur in the following form of x plus c, where there will be a horizontal shift, negative c units. So in this circumstance, if we shift to the right, that means our constant will have to be actually a negative 2. So here we're going to have f of x equals to the square root of x minus 2. And in this circumstance, we have to put it all underneath the radical inside of parentheses. Vertical shift we will keep outside of the radical. When it's not attached to the x, that's going to indicate that we have a vertical shift in the same direction of the sign. In this circumstance, we're going to have a horizontal shift in the opposite direction of the sign. So that sums up all these transformations, and this is really good practice for you to use. If you want to try further practice, you might want to try other graphs. You might want to try an example of a base graph of f of x equals to the absolute value of x. You might want to try another example of maybe a cubic function, and you might even want to try an example of, I don't know, a parabolic function, a quadratic. So each one of these are good examples of what you can manipulate using the same exact ways. And you might want to try to combine them. You might want to rotate around the x-axis and shift it down 5 units. How would you go about doing that? So working this out with your friends or with another colleague will really help determine your strength of identifying transformations of functions. So let us continue on now to number 9. I got a little mark here. Okay, so in number 9, we have to determine the equation of a line. Okay, so if we're thinking, first of all, okay, equation of a line, we know equations are going to fall in two forms. We're going to have our standard form, which is going to be ax plus by is equal to c, where your variables are on the one side, and then you're going to have slope intercept form, which is where you're going to solve for y in the form of mx plus b, where m is your slope and b is your y-intercept. So in order to write an equation of a line, in order to write an equation of a line, we need a point, and that's at 1. And then we're also going to need a slope. And we can get a slope by having 2 points. So in this circumstance, we have a intersection requirement. It says that the equation of a line will intersect the point negative 5, 1. So we have the point negative 5, comma 1. And it is perpendicular, which is the upside down t, to negative 2x plus y is equal to 3. So if it's perpendicular to this, we know that we can rearrange this form. We can rearrange this form into slope-intercept, because that way we can rapidly identify the slope of this line. So now, since we added 2x, this falls in the form of y equals m being the slope, and our m here is a value of 2. So since we know our slope is a value of 2, we now recognize rapidly the slope of this line. However, two lines that are perpendicular have slopes m1 and m2 such that m1 times m2 equals to negative 1, which really means that the slopes are opposite reciprocals. So their slopes are opposite reciprocals. So if the slope of this line is equal to 2, the slope of a line perpendicular will be the opposite. So it's going to be negative because this was a positive. Opposite will be negative. Reciprocal, so we're going to reciprocate or flip 2. So we're going to get 1/2. So now from this we were able to determine that slope right there. Now in this circumstance, we have now identified our two critical points. We've identified our point, we've identified our slope, and now since we've identified our slope and our point, we can go ahead and write the equation of the line. So I can go about doing this several different ways. I've given you many equations in this course. However, I do like using my super fast way to writing equations of lines, because as we advance through mathematics and chemistry and physics, we're going to be writing a lot of equations of lines. So we're going to take, and I'll do it in red, we're going to take the numerator value and place that in front of the x. We take the sign and we change it from a negative to a positive. You always change the sign. And then take the denominator value and place it in front of the y. So the 1 goes in front of the x. The sign changes, so I'm going to put a little triangle here to indicate change. And then we keep the 2 in front of the y. And then all we do is plug in. So now we're going to have 1 times x, but this is my x and this is my y. So I'm going to have x, which is negative 5. I'm just plugging in because that's what it says, plus 2 times our y value, but y is equal to 1. So I'm going to go ahead and simplify this. I'm still going to have 1x plus 2y is equal to 1 times negative 5, which is negative 5, plus 2 times 1, which is 2. So, and this is supposed to be a plus. So we're going to have x plus 2y is equal to negative 5 plus 2 gives you a value of negative 3. And you can leave it in this form. That's absolutely okay because it says it doesn't give a specific requirement for the form. And this is standard form. Standard form because your variables are on the same side. However, if you want to solve for slope-intercept, you're going to have to isolate the y. So we're going to subtract x on both sides. We're going to subtract x on both sides. And by doing so, we will cancel the x's over here. So we're going to have 2y is equal to negative x minus 3. Dividing both sides by 2 all around, we're going to have y equals to negative 1/2 x minus 3/2. So notice here, this will be our equation in slope-intercept form. So here we have standard form, and this is slope-intercept form.